Hello everyone, I'm Tạ Quang Tung. Today I'm going to introduce about elliptical cryptography. It's one type of encryption algorithm. But first, what is encryption? The definition is it a way to encoding messages that only authorized parties can access it. It's fundamental and also be one of the most important problems in security. We have two types of encryption. Each of them have its own advantage and disadvantage. Symmetric key cryptography and public key cryptography is also called asymmetric key cryptography. First, let's talk about symmetric key cryptography. Follow its definition. It is an algorithm using same key for encryption and decryption. It is very common from beginning of cryptography. It's fast to encrypt and decrypt. It also has small case size compared to symmetric key, but it has a serious problem because it uses same key. The key must be saved before any encryption. But if two persons never meet each other, how they can use symmetric key algorithm to communicate securely? That's why public key cryptography come into play. Unlike symmetric key, a public key algorithm have public key and private key. Normally, it's very hard or even impossible to derive a private key from a public key, but the opposite is not always true, and if some data are encrypted by public key, they can only be decrypted by using a private key, and vice versa. It has different advantages. The most important disadvantage is slow to decrypt and encrypt compared to symmetric key algorithm. It also has larger case size, but it's used in many applications such as exchange secret key, digital signature, and message authentication. One of the most common public key algorithms used today is RSA. Back to elliptical cryptography. It's a public key cryptography algorithm. It's harder to understand than RSA, harder to implement than RSA, so it is not common at RSA. But elliptical cryptography has its own advantages. The most important one is smaller case size. 160-bit key size of ECC is considered to be as secure as 1024-bit key size of RSA. So what is elliptical? What is an elliptical? The mathematical operation is defined of elliptical 2 square equal to x cubic plus a times x plus b, where 4 times a cubic plus 27 times b squared not equal to 0. And we have a special point, a point at infinity, also considered to be line on the elliptical. You may ask, why it has a point at infinity? I will answer this later on. Some example of elliptical. We can easily see that it is symmetric across its axis. The security of ECC depending on secret logarithm problem. But what is secret logarithm problem? Let's see be any group that define multiplication. For every element B of group G, the expression B power k equal to B times B times B, etc. k times. The equation B power k equal to A with B and A in known variable The solution K is called discrete logarithm of A to the base. If A and B is real number, it is trivial to find K, but in general, it is very hard. In ECC, multiplication is replaced by addition, but it still calls discrete logarithm. If P and Q are 2 points on elliptical such that K times P equals Q, if K is sufficiently large, it is computationally impossible to calculate K. Now let's talk about point addition. The ACC defines addition by using group theory. It divides by two not one basic operation, point addition and point doubling. Then when K equals to 23, the operation K times P can be expressed as P doubling P double plus P double double plus P double plus P double plus P. Then with any value of K, we can compute P by using just two operations. Let's see a geometrical explanation of point addition. In the first picture, we have P and Q. The line PQ intersects with elliptical at point R. Reflect R on the axis. We obtain R price, and R price equal to P plus Q. In the second one, we have point Q. The tangent line from Q intersect with the curve at point P. Replace P, we obtain P price, and it's equal to Q doubling. And the third and last one, the result is at infinity. We denote the point at infinity is 0, 0. So P plus Q equal to 0 and 2 P double equal to 0. Then formulate the equation. First come with point addition. Let P and Q at distinct point on elliptical is given by E square equal to X cubic plus A times X plus B. We define R equal to P plus Q that satisfies these equations. With point doubling, we now just have one point P, and we can calculate the result R at first base, except with lambda replaced by this equation. We now form a group of all points in elliptical and addition. Group and group theory. And point at infinity is identity element of that group. But the computer is very bad at real number precision, so we can't use it in cryptography. We need something better, something fast to calculate, and something accurate. We have two solutions using private field or using binary field. We now have intuition about elliptical and its operation. Let's see how it's used in cryptography. To use in cryptography, elliptical must share some domain parameter. We have A and B, the parameter of elliptic curve, and a chosen point Z on the curve, which is called a generator. And a cofactor with Z, we can form a cyclic group, and Rn is on the of that subgroup defined by Z, and a cofactor S defined by that equation, where the numerator is number of points on the elliptic curve. A prime number p in case of primary field, or a number of bit m in case of binary field. And in case of binary field, we must have another parameter, which is an irreducible polynomial. And with that, we can now generate public key and private key. A private key can be selected randomly of any integer that less than n, and public key can be computed by using dA times G generator. And with that public key and private key, we now can use it for algorithms such as ECDSA, elliptic curve signature algorithm, and ECDS elliptic curve Diffie-Hellman. Thanks for watching.